Hello, Algebra 1 students, welcome back. Today we are going to be doing change expressed as a percent. For the first three, we're going to be doing two different things. First, we're going to tell whether each percent change is an increase or a decrease, and then we're going to find the percent change. So for number one, we look at 72, the original amount, and then 67, and 72 goes down to 67, so it is a decrease. So that's the first part. And now we're going to find the percent change. So what we need to do is we need to take the original amount, 72, minus the new amount, 67, over the original amount. So that will equal 5 over 72, and that is going to give you 0.06999, and it says to the round to the nearest percent, so that rounded to the nearest percent is 7%. So our percent change is 7%. We're going to do number two. So the original amount is 36, and we go up to 68, so that is an increase. And now we're going to find the percent change. So for this one, we did the original amount minus the new amount. For this one, if we see 68 is bigger, so now we have to do the new amount for minus the old amount. So for percent decrease, we do the original amount minus the new amount over the original amount. And for percent increase, we do the new amount versus minus the original amount over the original amount. And that equals 32 over 36. Oh, sorry. 36. And as a percent, that'll equal 89%. I want you guys to do number 3 on your own, so pause it and then we'll come back and see if we get the same answer. Okay, I'm back. You can look and see what I did. We went from 16 to 11, so that's a decrease. And for a decrease, we take the original amount minus the new amount and divide it by the original amount. A little trick, if you don't know which one you should minus from each other, it's always the bigger number minus the smaller number. So we're going to move on to, I went one too many. Number 4. So for number 4 and 5, find the percent error in each estimation. So for number 4, you estimate that a building is 20 meters tall. It is actually 23 meters tall. So to solve these, we have to use absolute value signs, which means it just wants to know how far that number inside the absolute value signs is from 0. So the first thing we do is we're going to take an absolute value of the estimated value, which is 20, minus the actual value, which is 23. We take the absolute value of that divided by the actual. And then, so the absolute value, 20 minus 23 is negative 3, but with an absolute value sign, it's going to become 3 because it's just 3 units away from 0. So it's really 3 over 23, which is equal to, if you punch in your calculator and round it to the nearest percent, read the directions, it's going to be 13%. I want you guys to do number 5 on your own, so pause it and then we will come back and work it together. Okay, I'm back, and you can see what I did. I took the absolute value of the estimated years minus the actual years divided by the actual, so I get the absolute value of 7 over 37, and the absolute value of 7 is just 7 because it's 7 units away from 0, so it's 7 divided by 38, and then that will equal 18% rounded. I'm going to move on to number 6. Okay, for number 6 and 7, we are given a measurement, and then they're asking us to find the minimum and maximum possible measurements for the measurement they gave us. So for number 6, a nurse measures a newborn baby at 22 inches long to the nearest inch. So we need to ask ourselves, what is the smallest unit that she could have measured this baby to round to 22? So for minimum, oh, I need my pin. For minimum, if she's going to round to 22, what's the smallest it could have been? So the smallest it could have been was 21.5 inches, because that would have rounded to 22. So for maximum, what could she have measured to round to 22? And it would have been 22.5 inches. Because after that, you're going to round to 23. So that's all it's asking. So after you seen me do that, why don't you guys do number 7 on your own, and then we'll come back and see if we get the same answer. Okay, I'm back, and you can see what I did. So all we have to do to find the minimum for of 4, 3.5 will round to 4, and for the maximum, 4.5 will round to 4, but anything after 4.5 is going to round up to 5. So that's all it's wanting is the minimum and maximum. So I'm going to move on. So for the last two, the measured dimensions of a rectangle are given to the nearest whole unit. Find the maximum and minimum possible areas of each rectangle. So the first thing we need to do is you guys need to know how we find regular area for number 8. So to find the area of a 16 by 15 foot rectangle, we need to do 16 times 15 to find the area, which is 240. So the rounded area that we will get is 240. So to find the maximum area, so the maximum that number that could have been rounded to 16 was 16.5. And then we're going to times that by the maximum number that could have been rounded to 15, which is 15.5. So 16.5 times 15.5 is 255.75. And we're going to put our units, and area is always squared, so it'd be feet squared. So for number 8 minimum, the minimum number that could have been rounded to 16 would be 15.5 times the smallest number for 15 would be 14.5, and that equals 224.75, and our units is feet squared. So we're just taking the smallest number for the minimum that could be rounded to 16 and 15, and then for the maximum we just take the maximum number that could be rounded to 16 and 15. So I want you guys to do number 9 on your own, so pause it and then we'll come back and see if we get the same answer. Okay, I'm back and you can see what I did. The first thing I did is I found the rounded area, which would be 4 times 7, which is 28 centimeters. So to find the maximum area that it could have been, which would be 4.5 times 7.5, because those are the ones that are rounded, that would round to 4 and 7, is equal to 33.75 centimeters squared. To find the minimum, we round 3.5 to 4 and 6.5 to 7. So 3.5 times 6.5 is equal to 22.75. I hope you guys understand this. Bring your stuff to class on Friday, and I hope you guys have an awesome night.